If light has no mass, then why is it affected by gravity? According to Einstein's general relativity theory, light will be affected in the same way matter is affected by gravity. This is because under this theory, we should think of gravity not in terms of vector-like forces, but as a consequence of the shape of the universe. From Newton's point of view, gravity was a linearly directed force with which all objects with mass pulled on all other objects with mass. His analysis showed that the strength of the force was proportional to the product of the two masses attracting one another and inversely proportional to the square of the distance between them. Thus, an apple and the earth would pull toward each other, and the apple falls from the tree. Since light, whether perceived as a ray or a photon, has no mass, Newton's equation predicts that it will not be attracted by gravity towards anything, no matter how massive. In order to construct a theoretical framework that would be consistent to all observers and that did not rely on some independent fixed reference frame, Einstein had to discard this perception of how gravity works and devise a new understanding. According to this theory, all objects with mass alter the curvature of space-time, the four-dimensional fabric of the universe. Objects moving through space-time then simply follow the curves that have been created. Since human brains are not good at picturing things in 4 dimensions, we usually resort to an analogy in 3 dimensions. Imagine space-time as a sheet of rubber stretched flat when there is no matter present. If we place a massive object like a star in this space, it pushes down into the rubber sheet, creating a dimple or pit in the rubber. An asteroid flying by the star would not travel in a straight line as it rolled along the sheet. It would curve as it went through the dip, coming out in a new direction. If an object were going just the right speed, it might get stuck in the dimple and travel around the star in an orbit, like a ball around a roulette wheel. So far, the predictions of this theory are the same as Newton's, but now comes a big difference. If light traveled along this rubber sheet of space-time, it would follow the curve too, since the curvature of space is already created by the star. In fact, if the pit is deep enough and the walls are very steep, the light might fall into the pit and never escape. That's what we call a black hole. Newton didn't notice this bending of light because it takes very massive objects to get something as fast as light to curve enough that you can notice. This is the same reason we still learn and use Newton's equation. It works well most of the time, but experiments have shown that in fact Newton was wrong, and light is attracted towards objects with mass, just like Einstein's theory predicted. Thanks for watching.